there are 3 coins. Okay, we have 3 coins. One is a two-headed coin having head on both the sides, both the faces. Another is a unbiased coin that comes head 75% of the time. And the third is an unbiased coin. One of the 3 coin is chosen at random and tossed. It shows head. So we have an head, we have the outcome. What is the probability that it was the two-headed coin? Right? So first thing is, let's write what is that we have to find. So we are looking at the, how do I write this two-headed coin itself? Given we have a head as our outcome. So remember, the first thing goes along our x-axis. Do what? That is to coin selection. It's not actually selection, it's a pick. And along the y-axis, we have the count of a head. Okay. So now selecting a coin. How can we select the coin? Is there anything that we have a bias towards anything? No, right? So they have equal chances. So we have 1/3, 1, 1, and 1. So basically 1/3, 1/3, 1/3. Another is biased coin. Okay, the first coin is 1 is a two-headed coin. So here getting a head is altogether 100%. Right? And then another is a biased coin. So we are getting 3/4 of the time. So we're getting head 3/4 of the time. And this is tail 1/4 of the time. And the third one is unbiased. So this is unbiased. So we're getting head is half of the time. And tail is half of the time. So this is 1/3. Since I'm writing everything in terms of percentage, let me continue writing this also as 1/3, 1/3, 1/3. Okay, if you're able to draw this diagram, you're pretty much done. Right? So this is your two-headed coin. This is your biased coin. This is unbiased coin. Okay. Now, probability of head given two-headed coin into probability of two-headed coin divided by, since it's lengthy, I'm writing this way, probability of head when we have two-headed coin into probability of two-headed coin plus probability of biased coin into probability that we get head in our biased coin plus probability that we have unbiased coin and in this we get a head. So here we are making use of probability of favorable event formula and also probability of B given A formula. So number of elements that is common, number of outcomes that is common in A and B divided by number of outcomes in A. And now the answer. Therefore our solution is equal to, in the numerator we have probability of two-headed coin is 1/3 into, in that we'll getting a head is 1 divided by again 1/3 plus 1/3 into, here it's 3/4 of the scenario we're getting a head, and finally we have unbiased coin and the probability of getting a head over here is 1/2. Right guys, if you draw the diagram you're pretty much done. So 3 and 3 gets cancelled and we have 1/3 over here divided by, here the LCM is 6, no not 6, sorry, 12. Yeah, 12. 4, 3 and 2. 3 ones are 4s are, right? And this is 5 and 9. So 4 by 9. Right, guys, again, learn to draw the diagram. It's pretty simple, and be clear with what you're doing in each of this. First sequence is this, second sequence is this. First you'll choose a coin and then we'll toss. So that's the basic thing. This is actually not head, this is toss. Is it not? So this is, you're selecting the coin and this is toss. And within the selecting the coin, we have 1/3, 1/3, 1/3 chances of selecting any one of them. Equal chance, is it not? If it's two-headed coin, whatever you do, you always will get head. So 100% of the scenarios, you are getting head. Here, 3/4 of the chances that you'll get a head. Here, half. So if you're clear with this, then substituting, and of course, you need to know the formula, and you're done.